Hi everyone, I'm Erin Stellato from SQLskills, and thank you for joining me today, wherever you are in the world. I'm located in Cleveland, Ohio, in the United States, and as much as I wish I could be in London, it's not going to happen this year, hopefully next year, but I'm thrilled to be here presenting this session to you. So this session is stop tuning your queries and start tuning your workload. And just a little bit of information about me in case you haven't seen me speak before. I'm a principal consultant for SQLskills, and all the information about me is on the screen here, but the most important thing is my email address, erin@sqlskills.com. If you've got any questions that don't get answered today, and there will be opportunity for you to ask questions, you think of something later on, or maybe you want to discuss something in more detail, please feel free to send me an email, erin@sqlskills.com. You can also reach out on Twitter @Erin Stellato, but if it's more than 140 characters or whatever the limit is, just send me an email. That would be great. A little bit about SQLskills. We're a small team. Kimberly and Paul are the owners, and then Jonathan, myself, and Tim are additional consultants on the team. And I like to mention the team because sometimes I make reference to different members throughout a session, and I just kind of want you to know who they are. So in addition to training that we provide at conferences such as BITS, we also provide our own training through our immersion events, and those are completely online this year. They're running in October, and we'll finish up in October. I was trying to think of how long we were going, but we still have them going online this year. And we also offer services. So we offer consulting services, remote DBA services, and if you want to learn more about us or you want to hear from us on a regular basis, please visit our website. You can hit our training page, our consulting page, or sign up to be an insider if you want to get our bi-weekly newsletter. Again, here's some information about the different classes that we offer. If you go to our training page, you'll see that information in more detail. So this is the abstract for today's session. I'm not going to read it. I'm thinking that you've already read it, which is why you're here. But I am going to start by talking a little bit about why I wanted to do this session. And when we talk about performance tuning, it's not just good code. No solution, no environment, no code is perfect. I'm not saying that it needs to be. That's not the point of this session. But I'll tell you that I've seen some really good environments that run exceptionally well. And it's the result of thoughtful design, of good, solid coding, and continual tuning improvements with not just the code itself, but also the environment. And a lot of that comes from understanding the workload. So there's nothing that works all the time and requires minimal to no work, right? I always say that a database is a living, breathing entity. Very often your code base is as well, right? It's not static, it's continually changing. So when we talk about performance tuning, it's about knowing your schema, and beyond that, understanding your data and understanding your workload and what the priorities are for that environment, both at the business and the technical level, and then knowing how SQL Server works. And when you put all of that together, it's really not uncommon to start to see patterns, both in code and in performance. You tend to find them in code a lot because someone finds a way to do something and it works well, and then they show someone else, and then they show someone else, and it just kind of propagates. And so very often what we see in code manifests in potentially a good way, but sometimes not in a great way in performance as well. So this is kind of why I want to look at performance tuning holistically today, because those patterns are there and you can identify them. The other reasons that I think it's important to look at your workload on a proactive basis, and this is where I know it's tricky because a lot of us don't have a ton of extra time, right? Those of us who are data professionals, whether you're a database administrator or a developer or an application administrator who also manages the database, I know that you don't have a lot of time. So if we can look at things across the board, rather than trying to play whack-a-mole, right, and just address the problems one at a time as they come up, I think you can make better progress. And this becomes particularly important if you want to do something like consolidate servers. So Perhaps you've got smaller servers and there's this idea that you should put everything on one big server. I could tell you many stories about that, but I've seen that happen before. We had a customer who wanted to take all their databases that were on a Cisco M4 server, a bunch of those servers, and move everything, all the databases that were running on like 4 or 5 different M4 servers to one big M5. And it didn't work for them. And there's a variety of reasons it didn't. But when you look at doing something like that, because you're going to consolidate or because maybe you're going to go from a physical environment to a virtual environment, you need to think about tuning because you're changing up the environment, right? You also really have to think about tuning if you're going to migrate to Azure, because in Azure, you're paying for the resources that you use. It's a different model to think about. When we have a server on-prem, we've already paid for it. And so no matter how we use it and abuse it, we're not paying any more, right? We've already bought the hardware. In Azure, it's a completely different model, and it's really good to pay attention to how much you're spending. Ideally, in either scenario, you want to optimize before you migrate, right? Migrating and then having to deal with that and fix those problems is a lot more stressful than doing the work in advance. So I started, when I came up with this session, I reached out to a few friends and I'm like, what do you think are the typical performance issues in SQL Server? I had an idea of how I wanted to do this session, but I was curious to see what other people thought. And it's really funny. I got back a list of things, and it was a little bit overwhelming because I'm letting them come onto the screen here, right? But if we start looking at it, we're looking at things related to CPU. We're looking at how queries are written, right? With a select star or nothing in the where clause or the predicate, no indexing, poor storage, not enough memory, spills, hints, the way that the code is written, partitioning, probably not in an optimal format, or potentially for performance, not for management, over-indexing, inequalities in predicates, non-sargeable predicates, right? This is a really big list. And so I looked at this and I was like, this isn't quite what I was thinking of in terms of how I would programmatically or holistically look at an environment. And so I looked at these and then I started to figure out how could I break this down into a more manageable, groupable, maybe, set of problems. So this is how I ended up summarizing the performance problems. Set number 1 is those that are slow or take too long to execute. These are the ones that probably come to your attention most often, right? Because somebody has a query or a report or a procedure or a screen that has to render in a particular amount of time, and it's not happening. So very often, these are the types of queries that we hear about first, the ones that just take too long. Then we have those that execute with high frequency. On the SQLskills team, we tend to call these the death by 1,000 cuts because they're running over and over and over again, right? Very different than that which takes too long. On that take too long level, we also have those that consume too many resources or significant resources, more than we want. So a lot of I/O, a lot of memory, a lot of CPU, a lot of space in TempDB. And then finally, we have those that are very variable in performance. Sometimes they perform great. Other times it just tanks and we're not 100% sure why, but we know that life becomes difficult for us when that happens. So this is how we're going to look at these different patterns in query performance in this session today. And the tools that we're going to use are probably those that you are very familiar with. The DMVs within SQL Server, extended events, and query store. Now, I recognize that you all might not be on the latest and greatest version, and that's fine. That's why I've got 3 options here. Everybody has access to the DMVs, right? That goes back to 2005, and I'm really hoping that you're at least on currently supported version of 2012 and higher. I know there's probably some 2008 R2 out there. This really is targeted for more current environments. Query Store is SQL Server 2016 and higher. So if you're not there yet, that's fine. Or even if you are and you're not using it, that's okay. You still have two other options. Extended events is really what I expect people to be using in SQL Server 2012 and higher. And of course, if you're running Azure SQL, you have all of these available to you to capture this information. So there's some differences between versions. I'll point those out where I can. But let's revisit real quick what we get from each of these. And because depending on maybe what you're comfortable with, what you're familiar with, that may kind of guide which option you want to use here. So the DMVs are rehydrated, or not, they're not rehydrated, excuse me, they're not rehydrated. Those are information that's sitting in memory about the health, about the state of your instance, about your database, that once the server restarts, once the instance restarts, that information's gone, right? So I say it's transitory. And when we're talking about query performance and we're thinking about what's in the plan cache, that's based on what is executing or what has been executing. Anything that's executed weeks ago probably isn't in cache. Now, sometimes it can be. It depends on how frequently something executes, how big your plan cache is, whether or not your instance has been restarted. But if a plan changes for a query, that old plan is no longer in there, right? We only have the current plan for the query. And the data that's in the DMVs is an aggregate since that plan got into cache. So if we want to look at query performance over time, by default, we're not going to get that from the DMVs, right? We have to capture that or use a third-party tool, use Query Store for that. But the DMVs, I find, are very often the easiest place to start. Extended events requires effort in that you have to set up an event session to track what you're interested in. And you can run this for a particular amount of time. You can filter on different values, different columns, but you've got to set it up in advance. And then we have Query Store, which I'll be completely honest, one of my favorite features in SQL Server. Built in, you have to enable it, you have to turn it on, but once it's there, it's capturing basically everything you would get from the DMVs about query performance, and it's keeping it in your user database. So you've got a history of query performance. When you're looking at a system live, all three of these are viable options. When you're proactively looking at performance, all three of them are options because you're in control, right? It's not a reactive setting where you're responding and you have to do something quickly. So the DMVs, here's what we have going on right now. Extended events we can capture and look at immediately, or we can capture and look at later. And Query Store we can interrogate immediately, we can interrogate in the past. So three options that I'm really going to focus on today. So we'll start with our queries that take too long to run. And these are the ones that, as I said initially, are the ones that you tend to hear about the most because the users identify those as problematic, right? Nobody ever comes to you and says, excuse me, this query takes way too much CPU. I think that we need to look at it, right? The users don't know. That's not their job, right? All they have as a measure is time. So you'll often hear about these from your users. But remember that duration, query execution duration, may not represent the actual amount of work done by SQL Server. Think about blocking. From a user perspective, they submit a query and they're waiting and they're waiting, and it takes 5 seconds for the results to come back to them. And so to them, it is slow. But it's quite possible that for 4.5 of those 5 seconds, that query was waiting because it was blocked. It was waiting for a resource. And not until that resource was available could query execution actually complete. So these queries might be the easiest to find, but understanding why, such as the case of blocking, right, can take more effort. And I want to put up here, this is just a screenshot of the output from the DMVs. And typically when I'm saying DMVs, I'm specifically referring to those related to query execution. And you'll see this when we start to look at actual queries. But DMExec query stats, which is what this is a screenshot of, DMExec SQL text, DMExec query plans, right? So this is from DMExec query stats. And I point this out for a couple reasons. I just want to start as a reminder, or for those of you that maybe haven't dug into this too deeply before. We have in here creation time, which is when that plan was created, and then we have the last execution time, when it was most recently executed. And this indicates to us how long the plan has been in cache. So this one that I have highlighted here has been in cache for 8, 9, 10 days about. So it executes fairly frequently. If we look at the execution count to the right, we can see that. We have another plan that's been in there for about 4 days. Sometimes you have plans that are only in there for a few minutes. Again, there's a lot of factors at play here. But within this entry in dmexec query stats for the plan, we have not just the execution count, which I pointed out, but we also have information related to duration. But again, it's an aggregate since that plan has been in cache. So for this particular plan that I have highlighted on top, how long that plan's been in there, what are we saying, 8, 9 days, 10 days? And it's executed 30 million times, and we have a total elapsed time, and then the last elapsed time for the last execution, the minimum, and we have a maximum. And on the far right, we have an averaged elapsed time. That's calculated, right? That's calculated by taking the total elapsed time divided by the execution count. So we get an aggregate, and we can get an average through calculation. So when we want to look at what queries have the highest duration, the DMVs are the easiest place to start. So this is an example query that I use, and this is pulled from Glenn Berry's toolkit, his DMV toolkit. And I've got a link for that in the bottom here. It's in the resources as well. And again, this looks at total elapsed time divided by the execution count to give us the average elapsed time for queries. And that's how we're ordering. Now, sometimes you may, when you're looking at high duration, you may be more interested in not average duration, but total duration. So you may change that order by to just be total elapsed time. But again, this represents, through these DMVs, what's in the cache right now that's looking at, and in terms of the longest duration. So remember that if I want to proactively look at this over time, and I run this Monday at noon, what's in the plan cache Monday at noon might be very different than Monday at 5 p.m. and Tuesday at 8 a.m. So very often when we're using the DMVs, we have to trend over time what performance looks like. If we're going to use extended events, we're going to set up an event session that tracks SP statement completed and SQL statement completed. I call these the statement completed events. And we filter specifically on duration. And this duration's in microseconds. So this is 5 seconds, not anything crazy. It's in microseconds. And we're going to filter based on that and then run that for a certain amount of time. We're writing it out to a file. Once we've captured it, open up that file, sort by duration descending, and start to see what we have for our most expensive queries. We can also pull this information from Query Store. Query Store, like the DMVs, is an aggregate, and it does a calculation of average duration as part of its collection. We don't have a total there, we have an average. So we're just going to retrieve by that average duration. If we wanted a total, we would take the average duration times the count executions and get a total that way if we were interested in looking at the data a little bit differently. So I'm thinking that most of you are probably familiar with finding these that have the high duration, and these queries are a good place to start. Now, what if I want to find my death by 1,000 cuts, those that execute very frequently? The first question is, how frequently is too frequently? Is it 100 times a second? Is it 1,000 times a second? And there's no threshold that I can give you. It depends on your workload. So this is where understanding your workload, your environment, your code, your data really makes a difference. Because I know there are cases where queries execute where what I think would be ridiculous number of times per minute, but it's absolutely normal in that environment. So part of your proactive tuning also helps you establish some baselines if you don't have them already. The thing to really look at once you start to look at frequency is, are we looking at the same query that's executing over and over? And I'm going to show you something that I find really interesting that I don't know if everybody pays attention to, is queries that are exactly the same in terms of text and those that have different text but have the exact same query hash. Now, if you haven't looked at query hash and query plan hash before, a little bit of a review, right? These were added in SQL Server 2008. They are in dmexec query stats, which we are spending a lot of time in today. And this allows us to find the queries that are exactly the same syntactically, but they have different literal values. And there's a couple blog posts that you can look at here. They are older, but they are still extremely relevant, and I highly recommend them. A couple notes on the query hash. They're generated from the logical operators after parsing has occurred, and the queries don't have to have all of the exact same text to have the same query hash. White space and comments don't matter. Different literal values don't matter. The object names have to be the same. The aliases have to be the same. The hints have to be the same. The set options can change query hash. Not always. If they change the semantics, they will. But the query hash is not affected by the database or instance, which means if you are a multi-tenant environment and you have 50 copies of the exact same database on your instance, just with a different database name, but all the tables are the same, the queries hit the exact same tables. If you have a query that runs against all 50 databases, you will have the same query hash for all of those, which is great in that it makes it easy to find, but this can potentially cause a lot of bloat in your plan cache. So let's take a look at what this is and why I think it's a really interesting problem to review and try and solve if you can. I've already restored the backup from Wide World for Wide World importers, and this is the Wide World importers B. I think it's because I called it big at one point. I don't remember. But we've cleared out Query Store in here. I've enabled Query Store, and I've also cleared any history out. This isn't something I would normally recommend for production, but for my demonstration purposes, it's fine. Same thing here for free proc cache. Not for production. For my demo today, it's absolutely fine. Now, I'm going to create two procedures here. So this first one is kind of fun because even though this is a procedure, I generate dynamic SQL here, and then I execute this. So it actually executes basically as an ad hoc would. And we're selecting the color ID, the stock item name from the colors in the stock items table, and I'm passing in where color name is. And I'm passing just in a concatenated random string. I'm also running a query against orders and order lines for salesperson, person ID, order date, stock item ID, and here my predicate is customer ID. So I'm also just generating a random string here, a random number here as well. And this is just going to run over and over and over again. So we'll go ahead and create that stored procedure, which will generate ad hoc queries. And then I'm going to create another one, which looks just like my ad hoc one, except we are using variables. We're using parameters in here. So I am running each of these queries as a parameterized query with a value passed in. So these will continue to reuse the same plan over and over again. Go ahead and close that. And then we're going to start our workload here. So I'm first going to run just the stored procedure that executes the parameterized queries. So each one of these is going to execute 100,000 times. And it's starting to run. And these are all queries that I'm going to run together against just dmexec query stats. So everyone goes against dmexec query stats. But I'm pulling out different things. So I'm doing a count of the query hashes. I'm doing a distinct count of the query hashes. I'm also counting how many unique queries are in the plan cache, the number of plans, and the number of distinct plans using query plan hash. So we'll run all of these, and what's crazy is that all those executions finished already. So I have 10 unique queries in here, 13 plans, 12 of them unique, and I've got a list of the query hashes here and the number of unique queries. And if I wanted to say, okay, what do we have here in terms of those queries that execute most frequently? This is from Glenn's scripts. So we're just going to do top 50. And just like we were looking at the query for average duration before, this is very similar to that. But here we're going to order just by execution count descending. So we're going to get the top 50. And here we've got our SP random selects in here. And we've got, you'll see I have 3 different entries. And this occurs because I've got 2 different plans in here. And so this text is truncated over here, which is fine. I know that it's coming from this procedure. But we can see that these executed about 100,000 times each, right? But we only have a couple entries in the plan cache. And I can also pull this with a longer query here. That gives us same information, right? Query hash, query plan hash, the number of executions, and the text as well, and the object to which it belongs. So I can see that in this case, I don't have a lot of variability in my plan cache right now. So if you have a highly procedural workload, your output is probably going to have more rows, but it's going to look something like this. Now, what happens if I run that stored procedure that creates my ad hoc queries and executes those? So we'll run this, and this takes a lot longer to execute because rather than using that plan that's stored in cache, every single execution has to go through compilation, optimization, and then execution. So if we run this again, these initial queries against the plan cache, let me make sure that's running. So you'll see now that this has gone up, right? The number of query texts and queries that we had is in the thousands. We were at like 15 or 20 before, but the number of unique queries is extremely low. The number of plans, over 3,600. Number of unique plans is simply 6. So if we come back and let me come back up actually and rerun these the DMV queries again. So now if we want to look at what executes most frequently, this still shows up. But the thing is these queries are exactly the same, but they're only executing a few times. So we don't see that as the most frequently executed query, when in truth, it's one of the top. The query hash is all the same. So because of how we're looking at the data based on execution count, which is tied to the distinct query, we're not really understanding how frequently it's executing. If we use our other option here, now this one will take a little bit longer than it did before because we have a lot more information in the plan cache. This is going to show that in addition to the queries that execute most frequently based on that execution count, we'll also see those that are executing most frequently based upon the query hash because of this right here at the beginning. So let me just take this and drop that into a new window. And when I run this, right, you start to see that, and actually what happens is my stored procedure gets, I think, aged out of here, gets pushed out. But now we've got 2 different query hashes that have executed a few thousand times. And this is going to take a little bit because it's got to run through the entire plan cache at this point, which is now filled with a bunch of ad hoc queries. This shows up really well in Query Store. So here we go. So here's I do still have some information related to that stored procedure in the plan cache, but now you can see I have, based on this query hash, which is not tied to any object, right? This particular query here, here's the execution count. And I've got my other query that was based on the customer ID, which is executed a few hundred times. So the plan cache, if that's all I have available, it's a really good place to start. I think that Query Store really shines here. If I run those few queries to get the counts like I did against the plan cache here, I can see that I have 13,000 distinct query texts, but really only 8 unique queries, and over 13,000 different plans, but only seven of them are truly unique plans. So if I wanted to look for frequency in Query Store, I could approach this the same way I do in the DMVs, which is I can look by execution count descending. So let's run through that real quick. And while that's running, I'll take this other one and drop it in the other window. And obviously, right, actually, I'll tell you that I am not using, I'm not leveraging any indexes on the Query Store data. So depending on how big your Query Store is, which if it's an ad hoc environment can be pretty large, these may take a little bit to execute, but here we can see really well. Here are the 2 queries generated from my store procedure random selects, right? These are my parameterized queries, and we can see how many times they've each executed. Then from my ad hoc store procedure, these queries that have been executed as ad hoc queries, here with the same query hash, we've got an execution count of 15,000. The other one has executed about 9,000 times. I pulled a max for the text, so this is an example text, basically. But if we were to look at this, at the raw data, we would see different customer numbers for all those 15,896 executions. So let me make sure that that one finished up. It did, and that was the last query that I wanted to run there. So because Query Store has that historical data, we can look at the count of distinct query hashes over time, and we get a really good picture of how ad hoc our workload is. And I mention this because if you're using something like Entity Framework, Hibernate, Link to SQL, you do have most likely a very ad hoc workload. And you can do things to make that less ad hoc. And the easiest way to do it is to find the query hashes that are executing most frequently and start to see if it makes sense to parameterize those queries. Now, please understand that I'm not saying that that is the absolute solution here. So I have the queries that we were just looking at, I have here. So I'm gonna just kind of go through these rather quickly because we've already looked at them in the demo, right? You've got 2 options for how to pull this from the DMV. The option from Glenn, which goes based on execution count. And I know this text is really small. This was that bigger query that we were looking at against the DMVs, which pulls the query hash and groups by that, and then joins to that to pull the rest of the information. If you want to use extended events for high frequency, we're going to use the same statement completed events, SP statement completed, SQL statement completed, and we're going to collect also query hash and query plan hash. And then what you will do once you've got that saved out is group by the query hash to find what's executing most frequently. Now you'll note at the top, it says this is an expensive XC session. It has no filter on it. So this is a scenario when things aren't going well and for whatever reason we're not finding what we want in the plan cache, we could run this for a very short amount of time. Maybe it's only a minute. And sometimes what you'll hear us say is, we're gonna make it a little worse before we make it better because I need to see if that's what's going on here. But I grab that data, short amount of time, and group by the query hash to see how frequently queries are executing. Because if I tried to group by the text, they would not group together because of the different literal values. And again, the Query Store variations that we were looking at before in the demo, we ordered by count executions descending. And again, we pulled the top 25 based upon the query hash, the highest count there. If you're not sure what kind of workload you have, I have a post that talks about that in more detail, as does Kimberly. I would definitely recommend starting with those 2, along with looking at what data you have in your system. Now, as I said, If you find that you have a very ad hoc workload, I'm not telling you that you need to parameterize everything, but understand this. When you have plans that are cached and they're reused, that means fewer compilations, which means less CPU, and potentially queries that are running faster because they don't have to go through compilation and optimization. But the plan cache might not always be optimal for the different input parameters. We'll talk about this when we get to queries that have variability in performance. Statements, when they have their own plan, so every statement that gets executed is in the plan cache and it has its own plan, that's a potentially ideal scenario in terms of performance because that plan should be optimal for that statement, for those parameters. But for every query that executes, if we're getting a plan, we have a high number of compiles, we have a lot of CPU, and we have plan cache bloat. So this is what you have to figure out how to balance when we're looking at execution frequency for ad hoc queries and those that are running over and over again, right? If it's a really simple statement, and I've seen this before, something that queries based on a unique identifier, it does an index seek every time. If it runs thousands of times a minute, that's probably a good candidate for parameterization, and you just tackle those one by one. Now, queries that require significant resources, and here I'm thinking CPU, I/O, memory, TempDB. Your basic 4, right, where I tend to see big challenges. And even though maybe you don't have really high CPU, or maybe you haven't really seen resource semaphore weights, so you're not thinking that you have memory grant problems, doesn't mean that you don't have queries that are potentially problematic or are quietly problematic, right? So this is why I like this proactive approach. Now, we've spent a lot of time looking or talking about the DMVs and even a little bit about extended events in Query Store. So for this set of queries, you've got some good guidance already based on what we've already looked at. For the DMVs, again, DM query stats, that's the bread and butter. That's where we're going to go first. Looking at total worker time. And if you wanted to look at average, right, you take total worker time divided by count executions and look at it that way. In extended events, you're going to pull your statement completed events and you're going to filter on CPU time. Always put a filter in there when you can. And in Query Store, you're going to look at Query Store runtime stats, and that's going to be based on CPU time, whether you're looking at average, total, min-max, etc. Really, the easy button in Query Store is top resource consuming queries report, and look at either the average or the total CPU. I'll point that out to you in the next demo. Now, this pattern is pretty much the same. When we talk about high I/O, again, we're going to the DMVs, but now we're going to look at total logical reads. For extended events, I'm pulling those statement completed events, and I'm going to filter on logical reads. Query Store, same thing. Runtime stats, look at logical reads there, either average or total, max or min. And top resource consuming queries, that report also has information for high I/O. Memory grants are a little bit of a different beast. We still have the same approach in terms of where we can go and look at our data. So for the DMVs, we can look at total grant. In extended events, we can look at memory grant usage. You may also need to capture the statement events to correlate the memory grant usage event to the actual statement. So the extended events is not typically where I would start. I would start either with the DMVs or with Query Store, looking at the total amount of used memory. Now, memory grants, I find that this is something that most folks don't look at until it becomes a problem, and it becomes a problem in terms of resource semaphore weights. And when you've got resource semaphore weights, then you're going into DM exec memory grants because you're looking to see what's got a lot of memory granted right now, what's waiting. But you can use the DMVs and Query Store to be proactive and understand what is getting reasonably sized memory grants at this time. TempDB spills, I find, seem to show up in the data a little bit more. Again, same pattern in terms of the DMVs, extended events, and Query Store. DM exec query stats, we look at total spills. That's available in later versions of the DMVs. If you're back in 2012, you won't have that, or 2014. It's in a later CU of Service Pack 3, I believe, in 2016, 2017, 2019. With extended events, 2012 and higher, you can do the hash warning and the sort warning, and there are other spill events, but hash and sort are where I would start. Those are part of the default trace, so you're getting them already, but you need to correlate those to the statement. So that's where I tend to use extended events to get the statement completed events and pull together the data that way. And then in Query Store, you've got TempDB space used, available through through the system views of Query Store runtime stats, or you can use that top resource consuming reports and look at the TempDB use that way. So that's a pattern that I'm hoping, right, in terms of how we look at those, that you're familiar with based on looking at things on duration, which we talked about in the beginning. You can look at any of these other resources in the same manner. We'll circle back to this memory grant in TempDB when we're in this example talking about queries with variability and performance. So very often, I think that my queries that are parameter sensitive, that have different input values, and I get different plans, or when I have the same plan but different values, they're all over the place. These are the ones that can really vary in terms of the performance. Sometimes they're great, sometimes they're not. In some cases, you might find improvement with adaptive joins. Those are introduced in 2017 and higher. Memory grant issues can cause that variability as well, which may be improved with memory grant feedback if you're on 2017 or higher. Column store in 2017, batch mode for row store in 2019. And then if we're spilling to TempDB, depending on how much data we're spilling to TempDB, that can cause great variation in performance. And then you've also got blocking. So these are the ones that I think are most interesting to try and track down. So let's look at a quick example of how we can do that. We'll go ahead and close this window and this one. I think all of my other queries finished executing. They did. That's great. So for our variability, we're going to make sure that we're using the latest compat mode, 150. And we're going to set our database scoped configuration to have row mode memory grant feedback off. This was introduced in 2019. In 2017, memory grant feedback was available with column store. 2019, it's also available with row mode. We're going to create a procedure which goes against orders and order lines, and we're searching based upon the order date. So we're giving it a range. So we'll go ahead and create that procedure, and we're going to run this 5 times real quick with a very small date range. If you notice, this is just a week's date range. And if we look at our output, we get about 2,000 rows in this output. And I'm going to go ahead and turn, actually I don't need to turn the plan on here. So let's look here at the memory grant info in dmexec query stats. And I'm just pulling the memory grant specific info here. And what I really want you to notice is this min used and the max used. It's 432. Okay. Now remember, this plan is cache. This is a procedure, right? So we're going to go ahead, let me scroll back up, scrolling all over the place, and execute this again, but now we've got a bit of a wider date range. We're talking 6 months instead of a week. And we'll execute this 5 times as well. This is going to take a little bit longer, right? We're turning more data. Rather than the 2,000 rows or so that we were getting, this is going to return about 200,000 rows. And I do want to include the query plan here. When this finishes, I'll execute this one more time with the plan in place, because I want you to see what happens here. You can probably guess, right? When that plan was initially compiled for those 2,000 rows, it generated a memory grant because it has a sort in that plan. So here we can see, okay, this has about 2,000 rows. Let me just go ahead and turn on the actual plan, and I'll run that one more time. And while that's running, since I forgot to do this earlier, bear with me here. Let's just open up Zoom It. I don't think I've needed it yet. If you were all yelling Zoom It at me before, I do apologize. Let's go back there because I'll need that later. Okay, so this is finished, and you'll notice here that I have a sort. And you will notice that I have an exclamation mark here because this ended up spilling. So what has happened is that memory grant that I had for the number of rows that were going to come out of that clustered index scan was great when we returned 2000. But now that we're pulling out a lot more, right? If we look at here, what did we have? My estimated number was 1,400. My actual was 98,000. That had to spill. Right? But this was a cached plan, and if we check the memory grant information, because it's cached, it's reusing the same thing, and the max that it could have is 2624 KB, and that's what it used, but that's all it could do. And if we execute this one more time with an even bigger date range, let me come back here. So this is running. So this is a whole year. We're going to now pull a whole year's worth of data. And when this comes back, this brings back like 2 million rows. And we're going to have the same challenge where that initial memory grant that it's specified for this stored procedure, for this plan, is not adequate for this execution at all. But it's cached. There's, unfortunately, in versions prior to 2017, where you've got memory grant feedback, there's not a lot that you can do, right? This takes a ridiculous amount of time to execute. If I recompiled and ran these dates, it would generate a completely different plan, but it doesn't have an adequate memory grant, and so it's spilling to disk. So what I want to point out here is that because we don't have memory grant feedback enabled, I'm not going to be able to see in the plan cache or in Query Store that there's a problem. If I look, I'm going to show you here again in our plan. Here's our sort. I'll zoom in on that. We've got a spill again, right? The number of rows way higher than what we had before. So if I look at my memory grant information here, I can see that I still capped out at 2624. And if I look in Query Store, just for this particular stored procedure, this isn't really going to be any better for me. You know, I had this happen to me earlier today where I could not see that particular information. Let me see if I can find it this way. Actually, here's what I'll do. So we don't have to wait too long on that guy executing. Let me stop this one. Let me run it over here, and I'll move forward with this demo. Now we're going to turn memory grant feedback on. So I'll go ahead and turn that on. And now we're going to run this exact same procedure again. I haven't changed the stored procedure in any way. I just turned on memory grant feedback. So I ran it with the week date range. We have the same plan shape. I have no issue with my sort here at all. This is completely fine. Now we're going to run it again 5 times with the date range of 6 months. So this still takes a little bit of time to execute. It's still going to return the same number of rows as before, about 200,000 rows. No big deal. But because we have memory grant feedback enabled, it's going to recognize that the memory grant initially isn't adequate for the amount of data that's coming back, and it's going to change it. And that will show up within the plan cache. So when this finishes, let's see here if we can take a look at our execution plans once this finishes. There we go. So you'll see here that we have a sort warning on that first execution. But notice that on a subsequent execution, we don't, because the memory grant feedback has kicked in. And if we look in dmexec query stats, we will see that our min and our maxed use values are different than we had before. We had capped out before, right, at 24, 32 or something like that. We went higher. Now, if we execute this Last variation, 2 times. First time, it's still going to behave the same way, and it's going to realize, oh, I don't have enough memory. The second time, it will adjust the grant. So we're going to execute it twice, and we'll see that those numbers shift again. And I'm going to hop back over to this query store query, which just isn't helping me out at all. So I'm not going to worry about it. We'll execute this one. It takes a little bit of a while. I'll grab a sip of water while it's thinking. This is what happens, right? These are the queries that the users complain about, not understanding that it's a memory grant issue, not just a duration issue. So when this finishes up, we'll come back, we'll run this query again to pull the memory grant info. Again, returns 2 million rows. And today, I think my laptop has just about had enough as it's trying to run this query. There we go. Finished executing the first time. That one took over a minute to execute. Let's see if the second execution takes the same amount of time. And in this first plan, if we look at that here while that second execution is running, we can see we absolutely have that sort warning with the high number of rows coming out of that clustered index scan, way higher, than that initial estimate of 1,400. So still executing. I'll go ahead and wait for that to finish. I'm going to be surprised if it takes the full 2 minutes. Consider me surprised. That was 2 minutes at least. But it's about done. There we go. Finished up. If I look at the plan here, I still do have a sort warning in here. But let's see how the memory grant changed just a little bit, because I'm certain that it will. And it does, right? If I highlight these 2 columns, and I zoom in, right, this max use memory grant went way up. So how do I find these? I'm going to look at the difference between that min and the max. And let's see if my memory grant info shows up here in Query Store. If it doesn't, I'm not going to worry about it for now. It does. There we go. What I like to see. So now we've got this first row is likely from, this is from some of the first set of executions. They're all aggregated together here, the first round that we did and the second round. So we have a min and a max used here and a min and a max used for the second set, which are across different intervals of time. And we also have in Query Store standard deviation, which is kind of interesting to look at. So if we really want to find variability, our predicate is going to be looking at the difference between the min and the max. So here we're going to say where it exceeds 50 megs. And 50 megs may be really low in your environment. You may have to bump it up, right? This was about 80 megs in difference. So if we want to look at something that's variable when we have adaptive memory grants and can pull that, that's one way to do it. Within the DMVs, we could also look at TempDB use by looking at spills. So we can look for differences between the min and the max spill to find instances where we've got TempDB issues. And we can do the same thing within Query Store to find variability in memory use. I think I might have this set a little bit high for what we were looking for, or actually it's because our intervals rolled over when I wasn't expecting them to. But this will work as well. And as a reminder, because I had mentioned it, so let me just show you that really quick. Within my databases, within Wide World Importers, and within Query Store, it switched to a read-only state. If I want to come in here and look at top resource consuming queries at any point, I can look for, I just put this into a great state, didn't I? It's in a read-only state, and I'm not going to troubleshoot that. But this top resource consuming queries, in here I have the ability to change what resource I'm looking at, whether it's average, min, max, total, and I can dig into the worst case, the high resource use, as well as the variability in that top resource consuming queries report. So when we're looking at the variability in performance, the DMVs, we're going to dig into the DM exec query stats and look for differences between the min and the max. For extended events, the statement completed events, again, filter on CPU, duration, on IO, on something. Look at the query hash and the query plan hash. There, I want to look at changes in plan performance. So I would group by the query hash and by the query plan hash, because here I just showed you how to look for differences in min and max. The other variability is, what do I have for multiple plans potentially? I can't get that in the plan cache. I have to capture query hash and query plan hash to get it from extended events. But in Query Store, I can look for queries that have more than one plan. So I think that Query Store gives me probably the best option to find the queries that have great variability. But if it's not something that you have enabled, that's okay. You have a lot of great information in the DMVs with extended events as your backup. So in summary, you have a ton of options for finding performance patterns within your environment. DMVs, Query Store, extended events. And I say ton because there's a lot of different ways to use those three resources. Figure out what is readily available to you based on your version and what you're most comfortable with. I use extended events. Don't feel like that's a challenge you need to take on if you're not quite there yet. It's easiest, I think, to start with the DMVs. Save extended events for deeper troubleshooting. And if you've got Query Store enabled, I definitely recommend that you leverage that. So start simple and work up, and then you can start to find those patterns. So I have a few resources here in case you want to start to dig into any of this in more detail. And again, if you've got any questions, please feel free to send me an email, erin@SQLskills.com. Thank you for tuning in today, and I hope you have a great rest of the conference.